Right. Good afternoon. So I had a network issue in the morning. That's why I couldn't take the class. So I don't know whether you have the free time now, but I have to conduct the class. That's why I have scheduled that. Okay. So let's start the class. So we started unit number 5 in the last class. So unit number 5 is named as physical computing or something in your book. But I took that unit as logic gates or logic, simply logic gates. Okay, but your book has a different name. So names are not matters. We have to understand the fact in the unit. That is the very important thing, right? Okay. Anybody, what is logic gate? You don't need to.
Sir,
Wait 1 second. Anybody, what is logic gate? You don't need to copy the same definition given earlier. If you understood the, understood the word or understood the function, you can give in your own words. You may define the meaning by using your own words. It's not an issue.
so the electronic circuit that get electricity and perform something inside and do a special function.
Okay, but better to include those inputs and output in your definition, right? Yes, good. Logic gate is an electronic circuit which takes the electricity as inputs, and after performing some specific functions, it produces the output. So the basic idea of a logic gate is to get the input and doing something inside and providing the output. So I have explained using this block diagram, right? Hope you remember this. So 2 wires are taken. These are wires, wire A, wire B. So I take these 2 wires because to supply the electricity, right? So now this is the logic gate. Okay, this is the logic gate. So when electricity is supplied through these 2 wires, something happens inside. We don't know what happens, right? Later we will discuss. Something definitely happens, right? As a result of that function, there will be an output, right? So this is also a wire, right? This is the wire for taking the output. Sometimes that output is electricity, sometimes it is not electricity. We will learn, right? Today we have to learn that. So this is the basic idea about a logic gate. So inputs are given, some processes taken place inside. As a result of that, we get the output. Okay, right. Right, look. Then I told you that there are many logic gates available in electronics. We use many logic gates, but all these logic gates can be divided into 2 types. What are the 2 types?
Basic logic gates, combined logic gates.
Yes, basic logic gates and combined logic gates. So sometimes called combination of logic gates. Basic logic gates, combined logic gates. But for us, for grade 8, we have only basic logic gates. But I have listed the combined gates also because you have to get an idea. You have to get an overview. That's the reason why I have shown both basic logic gates as well as combination of logic gates. But for you, only basic gates are needed. So tell me, what are the basic logic gates?
And logic gate or logic gate, not logic gate.
Yes, all these logic gates have special names and or not. So you have to write them in capital letters. Okay, you can't use small letters, capital letters. What about the combined logic gates? What are they?
Non logic gate, no logic gate.
Yes, NAND, no. NAND, NAND, NOR, no. Okay. Okay. Who knows the meaning for basic gates and meaning for combined gates? Can you explain that one? Why do you call that as basic?
Sir, combined logic gates are compound of the basic logic gate. They are combined with some basic logic gates. Basic
Yes.
logic gates are the compulsory for that. Therefore, it's called as basic logic.
Yes, good. Combined gates, actually, they are the results of combining two basic gates. I explained, right? So they are not special gate, they are not unique gates, they are the result of combining two basic gates, right? But when it comes to basic gates, they are essential, right? They are must, because without them, we cannot create combined gates. Without the basic gates, we cannot have any combined gates. That's why AND gate, OR gate, NOT gate are called basic gates. Okay, right. Today, we have to start basic gates. Here we have only three, right? We have only three gates. It's too simple to understand. We have only three gates. Let's learn them one by one. Let's introduce the first gate now. After that, I will take the other gates. Okay, right. For now, I have to introduce the first gate, which means AND gate. Okay, listen to me carefully. This is very important for your future studies also, right? This is available in grade, grade 11 or 10 O level. Even it is also in the A level. If you follow ICT in A level, definitely you will study about this one. Not only here, it is in science, maybe physics. It is because it's electronics. It is not only related to computer. It's a wide area. Even it is available in some other subjects, right? In some other advanced level subjects, even O level subject. You know this design technology or something there in grade 10. So it is there. In some other subjects also, this area is included, right? Look, for each gate, I have to explain three things. For each gate, for AND gate, for OR gate, for NOT gate, I will give you three things. I already told you in the last class, but I'm taking again. The first one, every logic gate has a symbol. So I have to introduce the symbol for each gate. That is the first one. Second one, every gate has its own function, which we call logic, right? Every logic gate has a special logic, which means a special function. I have to introduce that. Third one, as I told you in the last class, to understand the function of every gate, we have to construct or we have to design a simple electric circuit, right? We have to design a simple electric circuit. So these are the three things which we have to take. Okay, right. So let's take the AND gate first. Listen to me very carefully, because if you are able to understand the things about AND gate, understanding the remaining gates is very simple. And at the same time, for AND gate, definitely I will take more time than the other gates, because I also feel that when something is introduced first time, you know, the description or explanation must be very perfect and must be very deep. But if you understood that one, you can understand the other things, because other things also similar to this one. So there you cannot expect me to explain everything as we explained in the previous gate, right? So listen to me very carefully. I have to take enough time to explain AND gate. Okay. So first of all, the symbol for AND gate. Okay. So this is the symbol for AND gate. Maybe a straight line and a curve. The straight line may not be clear. I will draw it again. So this is straight and a curve like this. Okay, this is the symbol of AND gate. Right, look here. So what I'm going to do is going to insert two inputs. Okay, so let me take this input and this input. So I take this as A, this is B. Okay, look again. This is the symbol for AND gate. AND gate is an electronic circuit, so definitely it needs electricity, right? It wants electricity. To supply the electricity, I have two wires, wire A, wire B. You know, these are called inputs. Wires are nothing, they are for carrying the electricity to the gate, so they are inputs. To get the output as a result from the AND gate, I need another wire. Okay, only one wire, which means output. Okay, so this is output. Look, one thing, in AND gate, minimum you must have two inputs. Minimum you require two inputs. 3 inputs possible, 4 inputs possible. But for you, 2 inputs are enough because we are the beginners, right? So we are learning the fundamentals. So 2 inputs are more than enough. At the same time, output should be only one, right? Not only for AND gate, for all the gates, output should be one. So here the output is there. Okay, right. So this is the first one, right? Symbol has been introduced. The most important thing about a gate is the logic or the function. So we have to understand the function clearly, right? You cannot have any doubt. You must understand everything properly. So wait, I will explain everything. If you have any doubt, you can ask me once the explanation is over, right? Listen to me. So look here. Now these are two wires. So what I'm going to do is I'm going to supply the electricity in wires. Sometime I may stop the electricity, right? I have the freedom to supply the electricity or stop the electricity. Okay, look here. So now what I'm going to do is going to supply the electricity in wire A. Okay, wire A. And also in wire B. So both wires will carry the electricity. Look, I might have mentioned earlier, did I mention that 1 is used for electricity and 0 for absence of electricity? Did I explain that one? If it is 1, electricity is available. If it is 0, no electricity. Did I mention this one in the previous class?
Yes, sir. Yes, yes.
Yes, right? So look again, I'm recalling that one. If a wire has electricity, it is taken as 1. Okay? If a wire has electricity, it is 1. If a wire doesn't have electricity, it is 0. Right? Not only 1, 0, we can take similar, we can take some other words for the similar meaning. For example, if it is high, did I use the word high earlier? Yes or no? No. Okay, doesn't matter. If it is high, right here, I can tell you the wire A has high value. Wire A has high value. What does it mean? That means 1, right? 1 means electricity. So electricity can be 1, even it can be mentioned high. So if there is no electricity in a wire, it can also be called low. Low, 0, same. Even if a wire has electricity, you can say that it is true. Right? True. True means a wire has electricity. Say, I can tell you that wire A or input A is true. Input A is true, which means input A carries the electricity. If input B is false, which means input B doesn't have any electricity. Okay, if input B is false, no electricity is there, right? So this is false. Even you can say 5 voltage, 0 voltage. So 5 voltage means there is a current flow there, which means electricity is flowing. Okay, electricity is flowing, that can be taken 5 voltage, because generally 5 voltage current is used. So if a wire has electricity, that can be taken as 5 voltage. If a wire doesn't have electricity, assume wire B doesn't have electricity. So if a wire doesn't have electricity, we already mentioned 0, even low, even false. 0 voltage also set correct, right? 0 voltage also correct. So when a wire has electricity, there are so many words which can be used to refer that. 1, high, true, 5 voltage. If a wire doesn't have electricity, here also we have words to refer that, right? So we have 0, low, false, 0 voltage. But mostly we will work, or we will use ones and zeros, right? Mostly in logic gates, using ones and zeros is very simple, because only one digit, 1, 0. But if it is high or true or 5 voltage, there are many letters, more than 1 letters. So sometimes that may be little, issue, right? Little problem. So we find easier in using ones and zeros. Okay, right. So remember these things. These are very important. These will be very useful for even answering the questions too. Okay, right. Have a look at this. Now, assume wire A has electricity. So if it is electricity, you can put the 1 here, right? So it is 1. So now, okay, wire B also has electricity. So I take this as an assumption, right? I assume that wire A and wire B has electricity. Okay, this is 1. So now electricity is flowing, right? Electricity is flowing through both wires. Now what happens? Actually, this is the logic gate, right? Which means electronic circuit. There may be a diodes inside, transistor inside, right? So there may be some other components also inside. But this is only a symbol. That's why I told you this is slightly a complex concept. This is only a symbol for AND gate. But the real AND gate is not this one. The real AND gate is made of electrical components, right? Such as diodes, transistors, resistors. So this is just a symbol. So assume this is a symbol, but the real object is different. It has so many components inside. So now what will happen? Electricity is going through 2 wires, right? Electricity is going through 2 wires. There must be something happens inside, because you have some components inside. So some processes will be taken place. As a result of that, you will get an output. So as a result of that process, we don't know the process, right? But I know the process, I tell you later. So after doing some processes, you will be able to get the electricity as output. Again, see it. Wire A has electricity, wire B has electricity. Okay, so now inside of the logic gate, there will be an action happens. There will be a process taken place, right? As a result of the process, you have electricity as output. Okay, wait patiently, I will explain. So now, what I'm going to do is, I'm going to stop the electricity in wire A, right? In wire A, I will stop the electricity. So now assume wire A doesn't have electricity, which means 0. You can forget the first one. Huh? Forget the first one now. Forget the first one. Now, take the second one. Wire A doesn't have electricity, because I stopped that. So assume there is a switch or something. This is a wire, so I have a switch. but now I off the switch. So now no electricity, right? Okay. But wire B has electricity. Okay, assume wire B has electricity. So 1. So now what is happening? Through wire A, no electricity flow. But through wire B, there is an electricity flown, right? Okay, now this gate will do a function, right? Do an important function, right? As a result of that process, or as a result of that function, you will not get any electricity, which means 0. Earlier you got electricity, that's why I put 1, right? But now there is no electricity. Okay, right. So this is the second choice, right? Or second combination. Third one, I will do the opposite of the second one. So what is it? Now I supply the electricity in wire A. So wire A has electricity. Okay, wire A has electricity. But I stop the electricity in wire B. Okay, I stop the electricity in wire B. So here 0. So this is the opposite for the previous instance. So in the previous instance, wire A had no electricity, but wire B had electricity. But now wire A has electricity, but wire B doesn't. Okay, only one wire has the electricity, right? So now again, this AND gate will do a function. So as a result of the function, you will not get any electricity here. Now also you will not get any electricity. So which means 0. Okay. So again, look here. Earlier we gave electricity in both wires. In the second instance, we stopped the electricity in wire A, but we supplied the electricity in wire B. But as a third instance, we supplied the electricity in wire A, but not via B. Look, when I have 2 wires, I can do 4 different combinations. Okay, I have 2 wires, A and B. I can try in 4 different types, right? The last one would be 0, 0. What's the meaning of 0, 0?
Both wires do not have electricity.
Yes, both wires don't have electricity. Okay, wire A, wire B, both do not have electricity. Now, as a result of this function, here also no electricity. Okay, here also no electricity. So look here, only in the first instance, you get the electricity as output. So when both inputs are 1, you got electricity as output. But in all the other instances, you did not have any electricity. So can anybody tell me what is the behavior of AND gate? What is the function of AND gate?
The multiplication.
To work an AND gate, it needs at least 2 inputs. I means to supply of electricity.
Yes. So when only, listen to me very carefully, right? So you can compare your inputs and output to get the idea. Look here. In the first instance, you have electricity. But in the second or third or fourth, you don't have electricity. So you can easily compare your inputs and output and get the conclusion. So, okay, I tell you the function of AND gate, or I tell you the behavior of AND gate. So AND gate produces, I repeat it, AND gate produces electricity as output when all the inputs have electricity. I repeat it, AND gate gives electricity as output when all the inputs have electricity. I use the word all the inputs because there can be 3 inputs, there can be 4 inputs, but at the moment we use 2 inputs, but it is possible, right? There can be 3 inputs, 4 inputs. So have you understood? When all the inputs have electricity, there is an electricity found as output. Okay. Look at the second, third, fourth. When one of the inputs of AND gate doesn't have electricity, output doesn't have electricity. I repeat it. When one of the inputs doesn't have electricity in AND gate, there will not be any electricity as output. Look at the second one. Here we have 0, which means no electricity. Why? It is because of this 0. In the wire A, in wire A, no electricity. Yes, we have electricity in wire B, right? That is not necessary, or that is not enough. Wire A doesn't have electricity. That is enough. So that's why you got 0. Clear? Look at the third one. You got 0 there. Why or how? It is because of, look at the third one, wire B. In the third combination, wire B doesn't have electricity. So when a wire has no electricity, definitely output 0. In the last combination, all the inputs are 0. Wire A 0, wire B 0, that is 0. So this is the idea. This is the summary of AND gate. When all the inputs have electricity, electricity is found as output. When one of the inputs is 0, which means when one of the inputs doesn't have electricity, there is no electricity as output. This is AND gate. Have you understood the function of AND gate? If you have any question, you can ask me. So I already told you that 3 things need to be introduced for every gate. 3 things. Among those 3 things, 2 of them have been introduced. So what are the 2 things? Symbol. I already introduced the symbol. Just now, I have introduced the function of AND gate. What's the function? When all the inputs are high, which means electricity, output is electricity. When one of the inputs doesn't have electricity, output is not electricity. This is the function. Okay, look.
Sir?
Yes.
Sir, AND gate, what is the function? That means what it do?
No, later we can discuss about AND gate application. Don't worry about the application of AND gate. At the moment, you have to understand the function and the symbol. Later, I tell you why it is used, or in which places we use AND gate. Right? That is not necessary now. Even if I explain that now, you cannot understand. So now you definitely have that issue, because you may wonder why these things are available, or why do you learn such things? You may wonder, but definitely the answer is there, but not now. Maybe after some classes, maybe after 2 or 3 classes, you can come to that point. Okay, so keep that question. We can find the answer little later. Okay. Right, now look here, I put these 1s and 0s here, but I just want to erase them. Look here. Because writing these 1s and 0s here may not be a right way, so I just want to delete it. Okay, look. So what I'm going to do is going to show these 1s and 0s in a table. Okay, in a separate table. But I already wrote these 1s and 0s here, not only inputs, even I have written the output too, because to explain, right? Then only you can understand. But now you have some idea, right? So let me show these inputs 1s and output 1s or 0s in a table. Okay, right. So I will write here. So you have 2 inputs A, B. So let me write A, B. These are inputs. This is a table. I'm writing a table. And this is the output. So I will write the output too. Okay. A, B, these are inputs and output. Right, look here. So as we discussed, there were 4 combinations earlier. For A and B, we tried 4 different combinations, right? So I will write them here. Look, have a look at this. 0, 0, 0, 1, 1, 0, 1, 1. These are the 4 combinations which we tried earlier. But we may, or we might try in a different order, but doesn't matter, right? We tried these things. So what's the meaning of 0, 0?
No electricity for both wires.
Yes. So what about the second one? What's the meaning of second combination?
Only B gets electricity, doesn't.
Yes. Wire B only has electricity, but wire A doesn't. Third one?
Only A have electricity, B doesn't have.
Yes. Wire A only has electricity, but not B. Last one?
Both of them have.
Yes, both of them have electricity, right? Both of them have electricity, right? So I hope everyone understands the function of AND gate. So can you fill this column now? Can you tell me the figures?
0.
0.
0.
0.
Sir, 3 0 last.
What about second one? 0.
0. 0.
Third one?
0.
0. Fourth one?
1.
1.
1, right? So this is the table which shows the function of AND gate. Exactly same, right? Don't think that it is a different thing. No, this is the same thing which we already tried. But earlier we have written the inputs and output in the logic gate. But writing the inputs values and output values in a logic gate may not be good, because if you write them, your logic gate doesn't look good, because there may be so many ones and zeros. That's why I have written them in a separate table. So the reason for constructing this table is to show the function of AND gate. So this table is called truth table. Okay, don't forget these names. This table is called truth table. So this is the truth table of AND gate. So truth table is nothing. It's a table to show the function of a gate. So whoever sees that truth table can easily understand the function of the gate. So now see, assume this table is shown to someone. So I am showing this table to you. So when you go through this table, or when you analyze the table, you could easily understand that when all the inputs are high, or when all the inputs have electricity, output is electricity. In all the other instances, you don't have electricity. So this is very important because it shows the function of a particular gate. But here, this is the truth table for AND gate. Clear? So this is the symbol. This is the table for showing the function of the AND gate. Okay, look, one more thing. Look here. A is input, B is another input, but look at the output. I have written the output as output, right? As an English word, right? But not only for AND gate, in all the gates, you will get output. Even in later, we will study about OR gate. There also you can find the output. Even in NOT gate also you have output. So it is not good to write the word output for a gate, because the result of a gate should be output. In all the gate, you will find output. So look here, I didn't use the word input. Right? I don't use the common word input. I use the input name, AB. Similarly, it is not good to have the word output, because output is found in all the gates. So instead of writing the word output, I will specify the output. Definitely it is output. Everyone knows. But I should show the output produced by AND gate when inputs are AB. Look here. I have to write the output of AND gate when inputs are A, B. Look, this is very simple. This is the output of this gate. So you have to write the input first, A. Then the gate name. What gate is this? AND gate. So AND, right? A and then the next input, A and B. So this is the output. Definitely it is an output. But look, I don't use a common word as output. I use the exact output of AND gate. So your first input A, your second input B, the gate is AND gate. So that's why it is written as A and B. Right? But in logic gates or in electronics, we mostly avoid this method. Mostly we avoid because it may be slightly big because you have to write a word in between your inputs, A and D. The word AND has 3 letters, right? Sometimes it seems to be little big. So often we use a symbol for AND gate in logic gates. Definitely it is correct. This may be the right answer, but we often ignore that because we feel that it is little bit difficult to write it because look at the word, there is a word. So instead of writing A and D, we use a symbol for AND gate, right? Look here, this is the one which we often use, A dot B, right? A dot B, here dot means AND gate. So you can pronounce that as A and B. Even though it is dot, yes, you can say dot, but it is also good to say A and B because that dot refers the AND gate. Clear? So input A, input B, this is AND gate. So your answer would be A and B. That can be written in these 2 different formats. A and B, the word can be used, or even the symbol, that dot can be used, but mostly we use a dot. Okay. So even in the truth table also, it is not good to say output because you know the output. You can specify the output. So better to show A dot B here. Okay. So these are the 2 things about AND gate. So this is the symbol. This is the function. Or even we often call that as a logic, right? Logic of the AND gate, which means a function of the AND gate. About this AND gate, I should show one more thing. What is it? You have to build a simple electric circuit to understand this function. I can explain the need for building that circuit because you may have some issues here. For 1 second, listen to me very carefully. Look. I take one instant. Look at the third one, right? Look at the third one. Wire A has electricity. Wire B doesn't have electricity. Now, what I'm doing is I am justifying the reason for constructing the simple electric circuit because we need a simple electric circuit. There's a need. So I'm explaining the need, right? Look here. So this is 1, this is 0. Tell me, what will you get as output here? What is the output there?
0.
0, right? 0, no electricity, 0. Look 1 second. So now assume one of you has asked me to prove this answer, right? One of you has asked me to prove this answer, which means wire A has electricity, wire B doesn't have electricity. Look at the output of the AND gate, it is 0, which means no electricity. So now you definitely have doubt because you may wonder how it is possible to get 0 there. You may wonder how it's possible or what happened inside. You cannot see anything, right? This is just a symbol. You are unable to see anything. So you may wonder how 0 is taken as output. So if you ask me to prove that, I cannot prove. I cannot prove because it is just a symbol. So I can only say that A has electricity, B doesn't have electricity. This is an electronic circuit. It may have diodes or transistors and other things. So something will be happening inside, some actions or some processes will be happening. As a result of that, we are unable to get the electricity. We have zero. This is the only answer which I can provide. Not only me, all can provide the same thing. I cannot justify, right? I cannot prove the zero because this is just a symbol, right? This is just a symbol. But if you want to prove that, or if you want to study how it happens, you have to build a small electric circuit using batteries, bulbs, and you can understand the thing which will happen inside. Okay, in AND gate, there will be some processes taken place, right? We are unable to see that because this is just a symbol. But when we build a simple electric circuit, we can understand the logic, or we can understand the functions which will be carried out in the AND gate. That may be the reason why we want a simple electric circuit for AND gate. Okay, so I will explain that little later. But before that, we have to write these things. Okay, now, what is your last heading? Do you have any heading?
And logic.
Yes, sir. And
Yes, you have the heading, right? Okay, right. So better, you have the heading and logic gate. And now, okay, now, draw the symbol for AND gate. Straight away you can put it, draw it, draw this. Draw the symbol, show the input AB and show the output. You can show both, better show both A dot B and also A and B, both are correct. Do the first one. A, B, use the pencils. A, B, this is A dot B, O, A and B, both are same. Okay, so after that, put the subtitle truth table, truth table, truth table, and also write the truth table, draw the truth table, draw it as a table, 3 columns, A, B, A dot B. Finished? Okay, 0, 0, 1, 1, 0, 1, 0, 1. Here 3 zeros and 1. Okay, right. So before taking that electric circuit, better to write the function of AND gate. So after maybe below to this one, right? This truth table, write a paragraph. Write a paragraph. In AND gate, in AND gate, in AND gate, comma, put a comma, when only all the inputs, when only all the inputs have electricity, I repeat it, in AND gate, comma, when only all the inputs have electricity, comma again, the output is electricity. Output is electricity. Right, full stop and continue. AND gate produces, AND gate produces low output, LOW, low output, within bracket 0 number, right? Within bracket 0 in number. I repeat it, AND gate produces low output, within bracket 0. When, continue, when one of its inputs is low, one of its inputs is low. What's the meaning of input is low?
That means no electricity.
No electricity, right? No electricity. You must remember that. No electricity. Okay, so this is the function of AND gate. Right, look. So look, I have to construct that simple electric circuit using wires,
Sir?
batteries. Yes.
Sir? Sir?
Yes.
Sir, what is mean by gate, sir?
We already studied, right? We started logic gate. Huh? You were in the class, right? Last class. Logic is nothing. It's an electronic circuit. Logic gate, everything is same. It's an electronic circuit for performing an action. It is made of with diodes or transistors, right? Resistors. So we are studying about logic gates. Logic gate same. Look. So what I'm going to do is going to construct a simple electric circuit using batteries, bulbs, maybe wires and something, right? Because to understand the function of AND gate, look carefully because it's very important. If you are able to understand that simple electric circuit, that you can understand this AND gate. Okay, look, it's a very simple thing. I take two switches and a bulb, okay, and a battery. Okay, this is switch A, this is switch B, and this is a bulb. Let me label it as Q or something. Have you studied such circuits in science?
Yes, sir. Yes.
Yes, you might have studied. Okay, so this is not new for you. You might have studied something in science. So I have two switches, switch A, switch B. Now both switches are off, right? Both switches are off, and I have a battery and a bulb. Okay, so let's understand this this circuit. It's a very simple electric circuit, right? I have to explain the function, right? Look here. Better we can take a small small table to understand this one. Okay. Okay, but I put here. Look here. Switch A. This is switch A. Switch B. Switch B. And bulb Q. Bulb Q. Right. So let's learn the function of this electric circuit using the small table. Right. Look here. So now both switches are off. Listen to me. Both switches are off. When both switches are off, you know, no electricity flown, right? There is no electricity here. There is no electricity here. So when switches are off, we can take them as 0. Okay. When a switch is off, that is taken as 0. When a switch is on, that can be taken as 1. This is the fixed meaning in electronics. When a switch is off, that is 0. When a switch is on, that is 1. Okay, so now see both switches are off. So switch A 0, switch B 0. Okay, right. Now look at this electric circuit. Take your time and tell me the bulb. Will it work or not? What about this bulb?
No,
Will
it
work?
cannot work.
Can't work.
It cannot work.
Yes.
Can't work.
Yes,
No work.
because you know there is no, see, the electricity starts here, and now when it comes here, it cannot be passed there because see there is a switch which is off. So electricity never goes here. So it never works. So bulb doesn't work. So I can take that as 0. Okay, bulb doesn't work because there is no electricity. So I take that as 0. Right? So now what I'm going to do is going to on switch B. Okay, going to on switch B. So now switch A is off, so which means 0. Switch B is on. So what's the value for B now?
1.
1.
Right? It's 1. I repeat it. Switch A is off, so 0. Switch B is on, so that is 1. Now tell me the bulb. Tell me the status of bulb. Will it work now?
No,
No.
0.
Yes, now also it doesn't work because look at that. Electricity comes here, but switch A is off. Yes, switch B is on. But even though the switch A is B is on, electricity never goes because it is off, right? So bulb doesn't work. This is 0. Okay. Now I will do the opposite. Let me on switch A, switch B again, and switch A is off. Switch B, right? Switch B is off. Switch A is on. So switch A on 1. Switch B is off 0. What about Q?
Bulb doesn't work. 0.
Yes, now also it doesn't work. Okay. Now electricity can go beyond that A, right? It can go here, but B is off. So it never goes beyond B, right? So it doesn't work against 0. Last one, last possible combination is on both switches. So now I own both switches, switch A1, switch B1. What about bulb now, Q?
Bulb burns one.
Bulb burn.
Now bulb works, right? You can see, you can clearly see the electricity can flow there, right? Electricity can be flown and circuit can be completed. It can go like that. Okay, circuit can be completed. Now bulb works. That is one. So now look here, this is the truth table which we earlier constructed. But this is not the truth table, right? This is not the truth table. I put this table in order to understand the function of this simple electric circuit. Because if I explain only in sentences, you cannot understand. That's why I have put it. But now try to compare this table and your and your truth table. This is truth table. Compare these two tables. Are they same or different?
They are same.
Are they same or different?
Same, sir. Same.
Yes, definitely same. See, 0, 0, 0. Here also 0, 0, 0. 0, 1, 0. Look here, 0, 1, 0. 1, 0, 0. Here 1, 0, 0. 1, 1, 1. Here 1, 1, 1. So now everyone knows that this table and this table is same. Okay, right. So if you agree that this table and this table is same, definitely you have to agree that this circuit is equal to the AND gate function, right? This circuit is equal to the function of AND gate. Okay, this circuit is equal to the function of AND gate. So earlier I told you, I asked one question. See, look at my question. I already told you, okay, A is 1, B is 0. What will you get here?
0.
0, right? 0. So this is 0. But if some of you ask me to prove that, say you ask me to prove that, I cannot prove. I could only say that something happens here, right? When electricity is flowing in A, but not in B, something happens inside. As a result of that, there is no electricity. That is the only answer which can be provided by me. But now think about this one. Now I can clearly say, now you're asking the same one, right? 1, 0. 1 means, look at this one, switch A is on. 0 means switch B is off. So now you're asking the same thing, right? The third one, right? Third one. Switch A 1, switch B 0. So now you may ask how it is 0. How it is 0. Now I can prove that. See, I can tell you that, okay, electricity is there, but switch A is off. So since switch A is off, electricity cannot pass that or cannot go beyond that mark. So circuit is not completed. So since circuit is not completed, bulb doesn't work. So in order to prove or in order to understand the logic of the AND gate, we construct that one. So as a student, what you have to understand here is, this is a symbol, right? I clearly told you this is just a symbol, but the real AND gate is different, right? The real AND gate is different. It is built by using several electronic components, right? Diodes, transistors, and everything. We just show only the symbol. So since it's a symbol, you are unable, or we are unable to understand the function of the gate. So what we can do is, we can create a simple electric circuit and understand the function of it. So now we can understand the similar thing or similar function will be happening or will be carried out in AND gate. So here we connect the two switches as serial, and because of the serial connection, we can get the idea. That's it. But the AND gate, maybe the real AND gate is different. Okay, so this is the logic, this is the electric circuit for AND gate. This is only for understanding the function of AND gate. But don't think that it is AND gate, right? This is not the AND gate. This is only for understanding the function of AND gate. Okay. Now you can understand when both switches are off, this is 0. Even though when A is off, this is 0. Here B off, 0. When only all the switches are on, output is 1. This is similar to the AND gate. Okay. Time up, right? Okay, better. I take 1 or 2 minutes. Quickly write it. Maybe in the next line. Write it quickly. Next line. The following simple electric circuit. The following simple electric circuit. The following simple electric circuit shows, I repeat it, the following simple electric circuit shows, SHOWS, shows the function of AND gate, the function of AND gate. Okay, so draw this first and then write this table. Do both. Draw it first, that is the important one, but I put this table in order to understand the inputs and outputs, or status of inputs and output. So do it first and then second. Keep both switches in off state, like this, and switch. There is a bulb. I have labeled it as Q. This is battery. And here also switch A, switch B, bulb Q. Finished?
Yes, sir.
Yes, sir.
Okay, so for this unit, definitely you have to spend some time at home. For maybe the other units, I don't want you to spend the times at home because you can understand the things while you're in the class. But maybe especially for this one, because this is something related to some other areas, right? Physics, electronics, so you have to learn. But this is better this has to be introduced in grade 10 or 11, maybe that may be the right time. But here it was introduced very early. For grade 8, they have introduced. So even though it may be slightly advanced to you, you can understand, right? You can understand, it's not an issue. So, but you have to listen to me, everything taught in the class. Reading or understanding the things written in the exercise book may not be enough. You have to listen to me everything in the class carefully. Then only you can understand. That's it. So send your names quickly, please. All right, so that's it. See you in the next class. Thank you.